Properties of quadratic functions. So for this section, there's a lot of different terminology that we're going to have to go through and learn. So a quadratic function is anything that can be written in the form ax squared plus bx plus c equals 0. And that's called general form. And its graph will always be a parabola. And that's what this is a graph of, a parabola. And from that, we have a vertex, minimum and maximum points, axis of symmetry, domain, range, and zeros of the function. So on this, first of all, we know that it opens up because the open part of the parabola is up. The axis of symmetry is this dotted line right here. And what that means is it's the line that intersects the parabola at the vertex, and it's symmetrical about this line. So if you were to take the parabola and fold it in half, it would be exactly the same on each end if you folded it on the dotted line. And because this graph opens up, we have a minimum point, and that's right here. So there's a minimum point. There's no maximum point. So whenever you have an open graph that opens up, you have a minimum point. There's no x-intercepts on this, and there's no y-intercepts. So for this one, we know that it opens down. And our axis of symmetry is the same. It's the dotted line. And now this time, we have a maximum point right here. So those are two examples of parabolas. For example 2, we want to graph this equation, and we want to determine the intercepts, the vertex, the axis of symmetry, the domain, and the range. So first of all, we can tell which direction the graph opens, and it's based on our a value. If it's positive, it opens up, and if it's negative, it opens down. So we know that it's positive, so our graph's going to open up. So that means we're going to have a minimum point. First, let's find our x and y intercepts so that we know where to graph them on the point, and then we're going to make a table of values. So for our y-intercept, all you do is you make x equal to 0 because it's where it intersects the y-axis. So y equals 2 times 0 plus 4 times 0 minus 6. So y equals negative 6. So if we take our graph over here, and I'm going to go up by 2's on the y-axis because we don't have enough room. So 2, 4, 6 right here. That's our point for our y-intercept. For our x-intercept, a different color, we need to make our y 0. So 0 equals 2x squared plus 4x minus 6. Now we have a trinomial, so we're going to factor. Or you can use whatever one you use the best. Factoring is quick. So 2 bracket x squared plus 2x minus 3. Find our two values that add up to 2, and multiply to get negative 3. And we should get positive 3 and negative 1. So it should be 2 bracket x plus 3, x minus 1 equals 0. So we want to find how we solve this. So x plus 3 equals 0, x minus 1 equals 0. So x equals either negative 3 or positive 1. So we're going to graph that. And on my x-axis, I'm going to just go up by 1s because we have enough room. So here at positive 1 and negative 3, we have intersections. From here, to find our vertex, we need to create a table of values and plug it into our equation. So I'm going to go from negative 4 -3, and -2, 1, 0, 1, 2. Let's do that many. And we know that our x-intercept is at 1, so this is going to be 0. I'm just going to put x-intercept. And we know that when x equals 0, we have -6, and this is our y-intercept. And at x equals -3, we have 0, and this is our other x-intercept. So we need to fill in the rest. So 4 times 4 squared, -4 squared times 2, plus 4 times -4, minus 6. Type it all into your calculator. You should get 10. So we're going to plot this point, 4 and 10, right here. If you plug in -2, you should get -6. So that's right here. And if you plug in 1, you should get -8 down here. And +2, you should get 10. So up here. And as you can see, it forms a parabola. And this is the parabola. Now, the way that you can tell what your vertex is that this is the minimum point it can be. It's right here. And it's where the numbers become going back again because they're symmetrical. So our axis of symmetry is right here also. So the coordinates for the vertex are at 1, -1, -8, and the axis of symmetry, I'm just going to put sim, it's going to be your x value, so x equals -1. Now for our domain and range are the last things. So our domain, if you could go left and right forever and ever, it'll hit every single x value. So our domain is going to be equal to all real numbers. So x is an element of the real number set. And that's all you have to put for domain. And for range, because we have a minimum value, we know that it can't go any lower than this point right here, which is -8. So we know that y has to be greater than -8. And it's also elements of the real numbers. So this is our range. So all real numbers greater than -8. Because it goes on and on and on and on up forever. And that is all the information about this graph. First differences is the difference between your y values, and it tells you whether or not something is linear, quadratic, or not. So linear, it's going to go up by the same amount, and quadratic, it's going to go up by a consistent amount. So for this one, to find your differences, first differences, you take the one below, subtract the one above. So this minus this. And you should get -3.5. Same thing, -5 minus -1.5. And you should get -3.5. -8.5 minus -5, -3.5, who would have guessed? And -12 minus -8.5, and you guessed it, -3.5. They all go up by the same amount, so therefore this is linear. So if you graph this, it would be a line, some sort of line. For this one, we have 5.5 minus -3, and you get 8.5. 14 minus 5.5 equals 8.5. 22.5 minus 14 is 8.5. And 31 minus 22.5 is, yep, 8.5. These are all the same, therefore this is also linear. If you go to page 255 in your text, we'll do that one as well. So for this one, we have -4 minus 1 equals -5. -11 minus 4 is equal to minus minus 4, there we go, is equal to negative 7. Negative 20 minus negative 11 equals negative 9. And negative 31 minus negative 20 equals negative 11. If you can see, each of these is going down by negative 2. Because this is consistent, we know that this will be quadratic. So it'll make some kind of quadratic function.